So hello guys, this is video number 12, and in this video we are going to do the ejection burn in order to get out to the moon. So we are going to continue our journey to the moon. So what we actually just need to do right now is that we just need to time warp until the DTE reaches about 40 seconds, and yeah, then we will do a prograde burn. When it's about 40 seconds, then we will burn the main engines. So this is where we want to raise our orbit on this side of the orbit. So therefore, so we can catch up to the moon. Then we will arrive at the moon, and therefore we want to burn at the opposite side of the orbit, and therefore it's the exact opposite side, this green dashed line here, where we are going to burn. So DTE is timed to this opposite node of opposite side of the orbit of this one. So let's time warp, and then at about 100 seconds let's start time warping, get back to real time, and let's put on the prograde autopilot. And as you can see, it says surface, so we need to press H a couple of times to get it to orbit HUD. So yeah, the autopilot, the prograde autopilot has settled, and we just need to wait for this DTE to be 40 exactly, about there. So fire now the main engines, press plus and hold the control. So what we need to do is that we need to wait for this DTE to be 0, and when it is 0, we will turn off the prograde autopilot, because then we will have enough thrust and enough velocity to keep us going towards in the same direction, just straight ahead of us, instead of rotating to some of the sides. So the DTE is 7 seconds, and we are about to cut the prograde autopilot, because then it will hold itself into position. And by having the autopilot turned on when it isn't necessary, then you're going to waste fuel, because it's using RCS thrusters to keep you in the autopilot position. So it will burst small engine bursts all the time to keep you in the autopilot position. So what we need to look for now is that we need to wait for this dV delta velocity to get down to 0. So let's press the translation linear, so we can use the translation thrusters in order to just correct the small amount as we are getting down and down, because we need to get this to 0.00. So let's just time warp until we get a little bit closer. And then we will cut the engines when we're about 0. So let's start to cut the engines, and let's use the translation process on the numeric keypad, the 9 and 6, to get rid of the last bit of delta V required. So now the dV reads 0.00. So what we need to do now is that we don't really need to do any burns right now. The thing that we need to do is that we just need to time warp. So let's just go ahead and time warp, because we need to time warp away from the planet. So let's just time warp, and let's see. So we are getting farther and farther away from the planet, and as you can see, this gravity, this G here, is going down, and the G is getting smaller because the gravitational influence is getting lower as we get farther away from the planet Earth. So as we get farther away, of course, then it will not pull as much gravity, and therefore the influence gets lower and lower. So let's keep time warping. Let me just look at our oxygen level, and we still have 41 months, so that's pretty good. So we just go ahead and time warp. So yeah, no problem, no big deal there. So let's time warp and time warp and time warp. And when this reads about 0.5 Gs, we will reference we will target the moon. So let's just go ahead and wait for that. Let's just time warp a bit more. And yeah, still 41 months. Okay, just need to be sure that we don't run out of oxygen. So we need to target the moon, celestial bodies, moon. No, that was actually wrong. Press NT to get rid of that, and then reference the moon. So this is the moon. So what we need to do now is that we need to just time warp until the orbit here. Now it says Earth, then it will say orbit Sun, because then the Sun is the most dominating force of gravity, and then it will be orbit Moon, because then we are closer to the moon. Now it says orbit Sun, as you can see, and now we need to wait for it to be orbit Moon. So let's time warp. Now we're getting pretty close, I think. So let's see. And there we have the moon. So we just need to wait for this to say orbit moon, and then we will stop the time warp. And yeah, so now it says orbit moon. So let's just rotate so that we can see the beautiful moon. Let's rotate over to the moon. So there we have the moon. So what we need to do now is that we need to bring up the map MFD, because now we need to make sure that we arrive at Brighton Beach, because this is our orbital path right now. Let me just go ahead and press display MOD orbit plane, so that we don't have so that we only have the orbit plane. Then let me target the spaceport Brighton Beach. So as you can see, we are not going to go past Brighton Beach right now, because our orbital path is pretty close to the equator and it's not going so much up and down. So what we need to do is that we need to raise the orbital plane, and we can do that by firing at either the normal plus or the anti-normal, the normal minus. So I think it's normal plus when you have to raise your orbital path upwards. So let's go into the normal plus position. And then we can press Control and then fire some little on the plus key. So now it's raising our orbital path. Now it's raising our flight path around the moon. Our orbit around the moon is now getting raised in order to catch up to the Brighton Beach. So let's zoom in. Let's add some velocity. And what I'm doing right now is just turn on the normal plus autopilot, and I'm just using the rotation to just go up past this crust here, because the PEA is coming up when I'm just at the crust, but when I'm above the crust it's coming down, and we need to raise our PEA. But this is just something I do to save fuel. This is really something that not something that we need to do. And now we're getting pretty close, and we can just stop the burn right now. So it doesn't have to be exactly at that point, because we need to make small corrections later also. So what we need to do now is that we need to find the moon, which is right there, and then we want to rotate, because we are facing the wrong way compared to the numbers here. So let's just press horizon level. No, that's for, yeah, that's actually for when you're in surface mode, and we are in orbit HUD, not orbit or not surface. So let's bring this down to the horizon right there. So let's rotate to get this straight, and a little bit down right there. So what we need to do is that we can either from here do an inward or outward burn, and I will explain what that means. So when we do an inward burn, then we will rotate to 70 degrees.
Okay, here comes the 12:22 to 12:23 time.
Then we will burn inwards toward the moon, in order to lower our periapsis, and our periapsis is pretty high, so this means that we need to lower our periapsis. But you can also do an outward burn, which will be 90 degrees. So it's always 90 degrees away from 360 degrees. So it's either to 70 degrees or 90 degrees. And here we can do an outward burn, as you can see, away from the moon, and that will actually raise our periapsis, because then it could either be very high or very low, and that would mean that you would actually need to raise your periapsis. But for this example, we are going to do an inward burn, because we need to lower our periapsis, and we need at final we need our periapsis to be at about 15 kilometers, because the highest peak on the moon is about 10 point some kilometers. But just to have some reliability when we're circulating the orbit around the moon, then we want it to be a little higher, just so that we have some flexibility in our orbit, so that we don't get any lower or much lower than that. So we will do an inward burn, and we don't need to use the prograde, retrograde, autopilot or something like that. We just need to burn. So yeah, let me just see what we need to do now. So yeah, so we need to of course lower the PEA. So we're going to burn, or first we need to time warp a little bit, because we can't really rely on these numbers yet, because they aren't really that precise. as closer as we get to full gravitational pull, 1.00, as closer we get to that, the more precise these numbers will actually be. So we can't really rely on this number right now from the PE abscess. So we need to time warp a little bit. And now we can start to do a burn. We can bring this down to 60. So let's go ahead and rotate back to 270 right there, and let's begin our burn. And this will rotate as we burn, so we need to use the 1 and 3 on the numeric keypad in order to keep ourselves aligned with the 270 degrees heading. So press the main engines, and the PEA is coming down pretty quick. And let's get it down to about 60. Right about there. Now we are about at 50, but that's okay. So what we need to do now is that we just need to time warp. We need to time warp until this gets pretty close to about 80 or 0.8 or 0.9. So let's time warp, and let's not waste any fuel right now because we're pretty unsure if this is precise enough. But now it's pretty precise. So at 0.89 usually you would actually need to lower this again. So now we need to bring the PEA down to, let's say, 16 kilometers because we're still a little out. So we have 1 kilometer of flexibility if something goes wrong. So because these numbers aren't really that precise yet, so let's go ahead and burn again. And let's burn, and just a small burn, of course, to bring this down. And we don't need time warp or just a big burst of main fuel because we aren't in a hurry. We need to do this with precaution because or else we will overshoot. So let's get this down to about 16 kilometers. And now we are at about 15 kilometers. Yeah, okay, so I overshot it, but that's okay. So what we need to look at now is that we need to look at the PET. So this is when we are going to do our other ejection burn in order to get in orbit around the moon. So we need to lower the other side of the orbit at the periapsis in order to close in so that we have a circular orbit right here. So let's just go ahead and time warp, and then we need this to get to about 60 before we do anything else, this PET. Then we will do a retrograde burn at about 16 seconds away from the periapsis. Let's just go ahead and time warp. And let's go into the linear thrusters, the translation thrusters, because we need to make small corrections soon. So let's go down to 1,000 before, and then I will explain something along the way. And the moon is coming into view right here. It's pretty nice texture. It looks very good. And the 2016 version has terrain on it, so that's why we need to definitely be above the terrain of the highest peak, which is about 10, if not 11 kilometers. So we need to have something. We need to have a safe distance from the terrain, and that is something that you shouldn't really care about in the 2010 version, but that would make it more realistic if you did hold an altitude of about 15 kilometers, if not 12. But now in the 2016 version we need to do it in order not to crash down into mountains and all that on the moon. So yeah, now the PET is 1000, and now I want to explain things. So yeah, what we need to do, that when we're 60 seconds away, we need to do our burn in retrograde in order to raise the other side of the orbit, so the opposite side of the orbit. So what we need to do is that, and now we can see the G is 0.99, which make these numbers very, very reliable and precisely. So very precise. So we can either do this burn manually, and there's also an add-on MFD which is much easier, called the burn time calculator, which figures out when to burn, when to do the injection burn or the insertion burn when you're arriving at the moon in orbit and you need to close in on the orbit, and then it will calculate when to burn, and then when it gets to around here, then it will start burning, and then it will do a perfect circular orbit around the moon, which is much easier than doing it manually, because when we're doing it manually we need to yeah, there's just something we need to do, because the PET, when we fire our engines, we need to do kind of a guessing game. So at 60, when the PET is about 60, we need to turn retrograde and burn. And then if the PET is counting up, the time to the period axis is counting up, then it's too early to burn, so we just need to experiment along the way. So let's just time warp right now. Let's not time warp too much, or else we will overshoot. We'll also need to get the retrograde autopilot time to sell. So yeah, let's just go ahead and turn to the retrograde autopilot. And let me just look at the fuel consumption. Still 41 months, so that's pretty good. So we shouldn't be worried about that. Definitely not. So that's very good. So now we just need the time to the periapsis to be at 60 seconds, and then we will fire to see, and not full main engine, but just a little bit control plus, and then just a little bit, just to see if this periapsis, the time to the periapsis is going up the PET. So we're about there. Press control and then plus, and let's see if it goes up. It doesn't, then you can add some more, and then keep on adding more as you get closer. Now it's counting up, so let's wait. So when this is about 30, then we can begin burning again. Then let's see what it will do for us. So let's see, 30. So let's begin the burn. And we can soon use the full power of the main engine. So at 15 seconds we will go ahead and use the full main engines right now. So now the PET is coming down, so we can just keep on holding the main engine button down, and now it's coming up again. So let's wait for it to be at about 8 seconds. And then let's try again. It's still coming up, so we need to get down to about 4 seconds, and still coming up. Now we can use the main engines. Still not. let's just burn until we get this pretty circular. So we can use the retro engines in order to make this more circular. Then we can use the linear thrusters in order to zero out the eccentricity. And now the eccentricity is 0.0001. Doesn't have to be perfect, and when you're doing it manually, it's sometimes pretty tough to get the eccentricity down to exactly 0.0000, but now we have it at 0.0001, which is also pretty good. We have the periapsis at 14 kilometers and the apoapsis at 14 kilometers, which is pretty good. So they are not too low. So this is very good. So let's take a look at the moon, which we can't really see right now because we're on the dark side. But yeah, let's turn off the retrograde autopilot. And now we did the insurgent burn. So what we need to do in the next video is just go ahead and come closer to the moon, set the docking frequencies and then, or the landing frequencies, and then land on the landing pad on the moon. So I will see you in the next video.